Hello.
Hello. Okay. Sorry, my microphone was turned off. I'm gonna redo that. So, hello everyone. Welcome to Pony Racing. This is the fourth episode, and the goal of this competition is for the four competitors to be the first one to solve a pwnable challenge, while me and my co-host Bob are providing commentary. So, I'm gonna introduce you to today's contestants, or rather, I'll let my co-host Bob do this. So, Bob, who are playing today?
Right, well, we have Mr. Tumble, who is a UK player. He works for Facebook in security, obviously, and he plays for Crown, which is an upcoming CTF team from the UK. And then we have Laxa, who is a French hacker, works for Synactive, has played. He's one of these people that got hired from CTFs, so he used to play for Go Root or 0x90 Root, as I pronounce it. And then later he moved up to KHack 40 and Team Baguette. And then we have a special set of participants because we were looking for someone from Opens Wall, and we ended up finding two of them. First, we found kileak, who is probably the top pwn guy from Opens Wall CTF. Really experienced guy, plays all the war games, CTFs, everything. Um, he's just top notch. And then last minute, Lord Idiot offered to play, so we have Lord Idiot as well. So we went from nobody from Open Wall ever to having two of them. And that's
Great.
it.
Yeah. So the participants are hopefully ready. So we're gonna switch over to see all of their screens. Yeah. So they should have all been provided an archive with the challenge, and I'm going to provide it to the viewers at home as well, since I know that a lot of people like to request it. So it's in the chat if you want to kind of follow along, but of course, don't communicate with the participants. Yeah, so I'm gonna check with all the participants. Are you ready and set up? Have you download the archive? Is everything fine? Kilik, Mr. Tumble,
Yep.
Yep.
Laxa, everything you ready?
Yes.
Lord Idiot, ready as well?
Yep.
Cool. So, we
Hang
are.
on one second.
Yep.
What's in connector.sh? Do I need that as well?
Oh, it's just the remote host. It's just
Right,
the
give me
the
one
host and
second,
the
I'm just gonna
port
pull
for
up.
when you're doing it remotely.
Give me 1 second, I'm just going to download that. Oh yeah, I see.
Yes. Great. So, then I think we are ready to start. So I'm going to, yeah, I'm just going to do a countdown, and then off we go. So, um, I'm going to first move you all over to the other channel so that you can't hear our commentary.
User was moved out of your channel. User was moved out of your channel. User was moved out of your channel. User was moved out of your channel.
Okay, so we are starting the fourth episode of Pony Racing in 5, 4, 3, 2, 1, go. Okay, Bob. So this challenge that we have here today, what are they up to?
Well, for thousands of years, man has asked the question, what can you do with a tiny format string bug that isn't located on the stack, where all the libc pointers have been cleaned from the stack and the environment is missing? And that's the purpose of today's challenge. They have a 13-byte string, or at least the string must be 13 bytes by the time it hits printf. It's a straightforward format string bug, and we're gonna have to see what they can do.
Cool. So let's go through their different setups and see what they are starting out by doing. So Laxa is waiting for Ida to start, and we have here Kileak. So startup IDA has a nice custom color scheme. We can see here.
Yeah, very nice.
And Lord Idiot is his streams seem to be something is this has happened before. We'll see. Hopefully it gets going again. So let's yeah, Lord Idiot's stream is a bit stuck, but we will sort that out. And yeah, mrtumble has also started this assembly in IDA. So all of the participants that we've seen use IDA this time, and that's what we've seen from all of them so far, right? Did we see anyone use Ghidra yet, or any other
Yeah,
tool?
Zap from RPI Sec used Ghidra.
Oh yeah.
We've seen Kira from Voss from LCBC. We have seen those first guys from Trail of Bits and Legit BS. They used Binary Ninja.
Yeah.
And then HPMV used Radara, of all things.
Oh yeah, that's true. It's true. And we got Lord Idiot's stream to work again, and yeah, he's using IDA as well, starting this initial analysis. The binary is quite simple. The main, I mean, there are a few functions that are interesting. It's the play, the input, the output, and the again function, right?
Yep.
And you can see right now here on Lord Idiot's view that there's this some mem set and allocations and stuff in the beginning of the function, and that might look very interesting, but it's actually just garbage to force the compiler to produce the right thing, if I'm correct.
Right, but then the mem set, that's just to make double sure that I don't have any, remnant libc pointers anywhere.
Yeah.
But the alloc was certainly to force something.
Great. So if we
and the binary is stripped and position independent executable.
Yeah, we can go here to kileak's stream. So he's already doing some kind of dynamic analysis here. Is he dumping stuff with the, yeah, so
Yeah.
he's dumping the stack with the format string vulnerability.
Yeah, so it's obviously useful for him to see what kind of pointers are already on the stack, because he's going to use those to write to something.
Exactly. Using Jeff, we have seen a few other participants using that. I think it's like the other alternative if you're not using Pwny debug, right?
Yeah, Hugsy's alternative. It's got some good stuff under the hood. It's definitely cleaned itself up, but personally I still use Pwny debug.
Yeah, same here. So
it is great for those situations when you're debugging on a low power device, like ARM exploitation or something.
Oh yeah, that I remember that we talked about that in the last episode, right? With and what was the reason for that?
It's just less resource heavy, I think.
Okay, cool.
But then Pwny debug, on the other hand, I mean, if you're doing Kimu pwns, so not on real hardware, then that is doing that fake VMAP stuff. So
yeah,
each tool has its strengths.
Yeah. We can see if we look here, for example, at mrtumble, trying to do some kind of overflow here in the input and like checking how that behaves. And that's the thing, right? You can input more than these 13 bytes, but if there's a string length checker.
Yeah, that's correct. So you can read a lot of data in, but the data that gets passed to the printf function must be 13 or less. So obviously you're going to need a null somewhere early on.
Yeah.
It's definitely not a buffer overflow this time, though.
No, we got a question here in the chat. Have these mainly been format string vulns? No, I think we have had one format string.
Yeah, one hybrid format string vulnerability, and then there's this one. I think every one that we've had, although there's an entry point vulnerability, we usually mix it up. So there's some sort of leverage or switch or pivot at some point. So this is no different.
Yeah. and that's kind of like the format we're going for, like small binaries with some kind of a slightly tricky challenge, but something that you should be able to solve within the hour or so. It's the goal,
Yeah,
at least.
usually like a chain of some sort, like as small a chain as we could possibly make.
Yeah, we look here at we can look at Lord Idiot's setup. He's
Ugly colors.
Oh yeah, it looks. I mean, he has this split view setup that you typically see. Like you have the debugger, the actual running the script, and your exploit, and you just going back and forth between making some changes to your exploit, running it, checking in the debugger, seeing what's going on.
Yeah, it's really great. I've recently tried to do some of this with Tmux in, you know, uh, different exploits, but the problem is that you can't really scroll in the debugger without some pain. You can't just use the mouse wheel.
Yeah, and that's a
But
problem since like Pwny outputs quite a lot of. I mean, it's really good information, but it usually doesn't really fit within a split view, for example.
yeah, exactly. So then I'm having to switch panes in Tmux, and it's a whole thing. I just haven't gotten used to it. Although it is interesting that he's using VI, so I like that.
Yeah, we can check in with laxa. He's started writing a exploit as well, and I think this is something we have seen quite with most of the players now here. And this is something we've talked about previously, is that they started very early to write, like to script this, to write an exploit to automate things. Even though they don't necessarily know exactly where they're going, they waste no time on doing stuff by hand, which they can automate.
Right, yeah. There's no point in wasting your time in the debugger feeding input directly when that might be useful in your exploit. But do you notice that with Laxa, look at the breakpoint that he set. So he knows that that's going to be the default address for this Pi executable. And he's not using that little tool that we discovered.
Oh yeah, we
The
should probably talk about that. So this is something that also have come up previously. The question of if you have a Pi executable, how do you set like breakpoints
yeah,
in a
for a
convenient
strict,
way?
yeah, for a strict Pi executable.
Yeah, for stripped Pi executable, exactly, where you only have the relative offsets. And in Pwnybug, there is actually a feature, and what's called break VA.
VA.
Yeah,
Yeah,
so break VA takes an offset and then sets a breakpoint in there.
yeah, really handy. I just
And
love that.
yeah, and it's good because also I guess if you do the use the GDB integration from Pwn tools, you can set these breakpoints before even starting the. So you can like break early in the program, I guess.
Exactly. So useful.
So that's a little bit one of the tricks that we discovered since, which at least wasn't known to us. So I guess a lot of people out there maybe didn't know about this. So checking in with Lord Idiot here, we see that he used a debugger to just dump a large chunk of the stack, I guess that was right.
Yep.
And also trying to just see what is on the stack, like what can we use.
Right, and the problem is that so obviously everyone knows that if you have a format string bug and you stick the format string somewhere else other than the stack, then you can't populate pointers. You can't forge pointers that you can write to or read from. So in this instance, we've done that. But what we've also done is we've cleaned all the interesting pointers from the stack. So there's no environmental variables, there's no argv, and then might have been overkill, but libc return main is also gone. So we've replaced that dynamically.
Oh yeah, exactly. So the first thing that happens in the main function is that it replaces the return address with the address of exit, right? So
So there's no libc pointers anywhere that they should be able to see. with that format string bug. There is an LD pointer, obviously VDSO, stuff like that, but it's kind of tricky. So it's a limited format string, and then you have that extra little hurdle.
Yeah.
But so
And
what do you do? You know, if people are watching and they think, oh, it's just a format string bug, what do you do in these situations? And it's interesting because this seems so artificial, and it is, obviously, but there is a bug that Zeta knows about where I used something very similar to this in order to pop that shell that seemed unpoppable.
yeah.
And that was in real life, so it just goes to show you sometimes real life is just as crazy.
Yeah, exactly. I mean, and that's I think we'll come back to this about the relationship between this and like the real stuff, and which there's sometimes critique about there not being a relationship, but yeah, we can talk later about why those people are wrong. So let's check here with for example kileak. He's made some progress again, looking through the contents of the stack, and it looks here like he's doing a partial overwrite here, right? Because you can see this HHN format string that he's using. So what is he trying to write
I think
to?
he's trying to, since he can write many times over, he's trying to write a pointer that then later he will, do something with.
Yep. And
And it looks like he's going to go with the brute force method.
yeah, I'm trying to see if we can see what his offset means, like what that points to, but I don't really see it, so we might discover it later. But yeah, let's check back with laxa. So also looking through, yeah, so there's a lot of like analysis of the stack going on, and that's kind of key to this, to find, I mean, what they're looking for is this chain of base pointers that's going to help them. And
Yeah, and that's where Pwny bug and Jeff or Geff or whatever really comes in handy, because it's dereferencing those pointers automatically. So you can kind of just see what's red is obviously executable memory, etc., etc. What's a stack address, and what things point to. So they're looking for something tasty that they can sort of write to.
yeah, because, and I mean, for those who are new to pwning, so the key here is that with the format string, if you control the first argument of the printf function, you can do a lot of fun stuff. The most obvious things being leaking memory from the stack, or using a pointer on the stack to leak memory from there. But you can also actually write data with the %n character, and that's kind of like the core mechanism here, to use the printf %n modifier or format string placeholder to write things. But what that does, it takes a pointer and then writes to that destination. So you need not only something interesting to be within reach, you need a pointer that points to something interesting, and that's kind of like a tricky thing to find.
And what it's writing is obviously the amount of characters up to that point that have been written to the screen.
Yeah.
So it's used to help formatting and complex formatting tasks.
Exactly. If you're
So
writing like a table with dynamic width columns or something like that.
Exactly.
So it has an actual real world use, but I'm wondering if it hasn't
does.
been used more times for exploit than for actual stuff. But
Possibly. I mean, Windows took it out ages ago,
yeah,
so maybe.
it's cool.
I think usually with these sorts of format string bugs, where it is located in, on the heap or in the data section or something like that, what they're looking for is an existing libc pointer somewhere on the stack, and then another pointer, a stack pointer that points to that area of memory. And then they will use that to write to a custom libc address, and then later they will write to that libc address. So usually it's like malloc hook or free hook or something like that.
Yeah, but that's going to be tricky then this time, because
Right.
there are no libc pointers available, so they don't know where libc is located.
Right. So they could forge a pointer probably, but it's a 64-bit binary on a machine with ASLR, so you're kind of limited in forging the stack.
Yeah. So let's check in here with Mr. Tumble, who is doing some kind of dynamic analysis here, breaking at this.
Pi break. Okay, so that's the Geth version.
Oh, cool. Yeah. Good to know for those who are using Geth. So he's breaking in this output function and trying to, just as this format string vulnerability is about to trigger, and then checking what's on the stack. So I guess maybe he's trying to find out, because like when you are inside of printf, there might be things on the stack that you have to move past before you kind of like get out to this frame that we are interested in, and it looks like he's trying to match the contents of the stack on that location with what he's dumped previously.
Right. But the first couple pointers that he pops with the format string bug will always, on 64-bit machines, come from the registers and not from the stack.
Yeah.
So that's why you sometimes have to like go, wait, where does it start? Where does it end? Sort of thing.
Yeah.
And the other thing is, you notice that he had check sec automatically to find out if it was NX and this or that.
Yeah.
That's usually like a great sign, for those first steps to kind of like get a feel for what kind of vulnerability it might be.
Yeah.
Although in this case, there's no canary, which to us would usually say buffer overflow. But there's another reason there's no canary, so sometimes it's misleading.
Yeah. So, yeah, it's trying to still exploring this format string leak. So if we check in then with Lord Idiot again, and his stream is fine. His cursor was moving. I was just afraid for a moment there that something broke, but yeah. So he has a comment here, write things, and he is also you can see this HHN format string placeholder to write a single byte, but the question is what is he writing, what value is he writing, and where is he writing it to? So
right, so obviously he's going to write 1 byte at a time from the edge rest thing, and here it's stack leak. So he's trying to forge a pointer on the stack, which is 12 pops in apparently.
Yep.
So what would he forge a pointer to? Remember, this is a full railroad binary, so you're not writing to the global offset table. Right?
Yeah.
That's off the chart here. So usually you'd be looking at libc hooks, or there's tons of tricks that you can use, some more esoteric than others. But in the binary itself, the usual thing would be to forge some sort of a pointer using an existing stack pointer, and then point that at the return address or something like that.
Yeah, that was what I was going to ask. Is that not a feasible thing, that you leak the stack one stack pointer, which is of course doable? You calculate where you are on the stack, and then you try to forge a pointer to one of the return addresses, and then just go back to that.
Sure, but then what? You don't know where system is?
No, but then you can do this the ropping if you
you could do a little rop pivot sort of thing, but you'd have to, you're going to do this remotely. You're going to have to write 1 byte at a time, and then switch the pointer again, and then 1 byte at a time. So you could do it. You could definitely do it, but it would take a little bit of time. All right.
Yeah. So I mean, that's at least it's not the intended solution, but it feels like it's a theoretically possible alternative solution.
Yeah, for sure it is.
And that is actually, I think, one of the first times we have seen something that we actually could work as an alternative solution. We've seen in some of the other episodes where people have been on like the wrong track, and we have been considering like, could this actually work? And so far the answer has been no. So yeah, we'll see if they'll find like the intended solution or do something more complicated. So yeah,
Yeah,
let's.
and they have to pop a shell. That's the important thing in this format.
Oh yeah,
Because
exactly.
we're not reading a flag. They actually have to run a program on the server.
Yep. So looking here at kileak again, still some dynamic analysis going on, dumping contents of the stack. Um,
He has some of the same setup though to write, a thing one byte at a time
yeah,
somewhere on the stack.
yeah. So he's created this like primitive, this function where he can do these writes. Um, but yeah, the question is what he's gonna do with this.
So David Buchanan asked, have those handy argv and nvp pointers been removed from the stack? Yes, they have. And then he says that there's some partial overrides. He guesses there's going to be some partial overrides, and that would be the exact thing that I would be looking for.
Yeah. So someone says, please include web exploitation and other challenges as well. We will. We hear what you're saying, and we will consider it. That's.
I will not consider it seriously.
Bob, don't scare away the viewers.
I'm not the nicest person when it comes to people from other categories. No, but obviously this is Zeta stream, and I'm sure he has grand plans and will accommodate everybody. I will accommodate nobody but the real hardcore porn people.
Yeah, I mean, this is still early days of this whole idea. I mean, as we've said, it's the 4th episode. The idea was to have a focus on pwnables, but we'll see what happens. There might also be like hybrid challenges popping up, possibly.
Yeah, that could be interesting.
But I think
I mean, there's certainly a lot of things that you could gain from this format, but
Yeah.
the original was pretty much reverse engineering. I think some crypto and then binary exploitation.
Yeah. And no, I think
Also-
like kind of in this like world of web stuff, we need some quality pwn content, right?
Yeah, that's the thing. Those web challenges to get at a high quality, I mean, there's only so many people that hit that mark, I feel, of something innovative and interesting.
Yeah.
Obviously, some of those people, so maybe it will happen.
Yeah. Yeah, no, let's I thought about levels that one of our teammates have created, and then I got some bad memories. So let's just move on and instead check in with Lord Idiot, who
Well, kileak got some seg faults.
so maybe actually check back with him. But I guess like getting the
Could be
program.
writing to bad memory.
Oh, was that what
like-
he did?
It could be. I don't know. I didn't see.
We can also see here that kileak has been running the one gadget tool.
Okay.
Which
And
for those
what
who
is he
don't,
using for libc? Where's he getting that libc address?
where is he getting the libc address? Are you saying?
Because he has it, and he has the base, so he has everything he might need.
Oh,
But
so
I
he
didn't
might
see
have
where he
found
leaked it.
an alternative
Oh yeah.
solution for this. Okay, so now we're gonna stay a bit on kileak's stream here to try to understand what's going on. So now he's going to try to run this with the target libc. That would be very interesting, because that I think would be the first time we had like an unintended solution for this, right?
Yeah,
And then
definitely.
he's turning. Oh, so he had turned off
Oh yeah,
ASLR.
he turned off ASLR. Okay.
Yeah. So maybe he's just planning ahead and saying and considering like, what if I knew the libc address.
Right. Yeah. But he is one to watch. If there's some trick, he's gonna have it.
No, it's interesting. But okay. So I think
Just a tip though.
Yeah.
You don't need to go as root and
No.
then do that echo to /proc/vm/ randomize in order to turn off ASLR.
No, I mean, there at least first of all, you can launch it from within. From within Pwn Tools, and you can also do like you can start um, a shell with ASLR turned off.
Yeah, like set arch,
Yeah,
and then
exactly,
uname m-r blah blah blah.
exactly. And I mean, if you really want to just turn off, you can always just do like echo pipe to t sudo t, and you don't have to
Yeah,
elevate
yeah.
yourself with su. But yeah, so there are multiple ways of doing that, but you definitely don't need to. You can start a subshell with ASLR turned off. Um, so yeah, but I think we got a bit overexcited about that, and like now when we realized that.
But what is he trying on the remote server? That's what I don't understand.
Mm, but is it though? Uh, oh yeah, there's a close connection to.
Yes, he's opening the connection and running it locally, like you did that time when you messed up.
Oh yeah. So maybe he did that as well. That was hugely frustrating. I thought I was running it locally, but I was actually running it remotely, and then I was wondering why none of my breakpoints were firing. And then I felt like an idiot when I discovered what I've done. So yeah,
And you should.
yeah. So let's check in with Laxa and doing some reverse engineering again here, looking over the code again.
Now he seems to be the only one smart enough to do this. And this, if those other guys don't get some unintended or novel method, this is what you want to be doing. Sure, you found the bug, but look over the whole binary, because
Yeah.
there might be some other piece of information that is going to help you down the line.
Yeah.
And he knows that. He's an experienced guy with these sorts of things. So I think that's what he's doing. He's just trying to understand the thing as a whole, because obviously he saw the format string bug. He understands how to exploit those, but I think he also sees the limitations.
Yeah. And also, he actually was the first one to complete both the last and the previous community challenge. Unfortunately, so he couldn't attend the last episode, so he tried again and was the first solver of
And
this.
he was really quick on one of them, wasn't he?
Oh yeah, was like we're talking. I mean, of course, I don't know when he started, but it was just a couple of hours after we had released it. So
Yeah, he can be quick. I've seen him in action,
yeah,
for like years ago, and he was even quick then.
yeah, that's interesting. But yeah, so he's still looking over that, and that's we'll see if he finds something. So we can switch over to Lord Idiot again, which is also now like taking a extra thorough look at the binary itself to see if he missed anything. And there's still like quite a lot of code in their exploits already, but I'm not sure it feels like they really know where they're going yet. I haven't really seen. I mean, the indication we're kind of looking for, which we haven't seen yet, is someone writing to one of the base pointers, right? So
Yeah. Look, on a format string vulnerability where the string is not on the stack, you're just looking for a pointer that points to something interesting.
yeah,
And all of these guys have looked for a pointer that points to something interesting, like some metadata, right? Like a return address or some interesting hook, some libc address. And isn't it amazing that every single one of these guys has missed the stored base pointers,
yeah.
which is metadata on the stack that, will influence control flow.
No, exactly, and it's very. I mean, all the functions in the binary ends with this leave ret construction. So you really have the setup, which is, I mean, the intended way to exploit this chain of linked base pointers to use one to overwrite the other, and then take control of the stack, basically.
You should probably explain leave red to like noobs.
Yes. So, I mean, when we enter the function, we have an existing base pointer, which we store, push it to the stack, and then we set the base pointer to the current stack pointer. But then we have to do the reverse thing when we finish the function. So we pop from the stack into the base pointer, or in which order is this performed, and then you set.
Yeah, you move the base pointer to the stack pointer. And
Exactly.
yeah. So it's like a pseudo assembler instruction that basically does this compound operation in 2 cycles. And it's just kind of interesting because it has all the influence you need to take control flow. So it's just something that I feel like people used to look for these a lot more. Like they would get, off by ones onto the base pointer or something like that.
Yep.
But nowadays, it doesn't seem so much. Which is why this came up, because I was talking with someone, and they just said that it was impossible. And I was just like, no, but like you have base pointers. And then, so I just wanted to see if these guys would be as quick to catch on.
Yeah. So an interesting thing here on mrtumble's screen, but unfortunately he switched away. He found it was some weird thing where it said like return address was assigned 0 or something in his disassembly or decompilation. I would like to switch back to that so we can see what was going on there. It looked a bit strange, but yeah, unfortunately I can't control their environments.
So that might indicate that he hit the base pointer, right? And then pivoted somewhere where it was nulled out, like down the stack where the environment used to be.
Yeah. No, this was in the decompiler, I think.
Ah, gotcha.
So, but I just saw it briefly on one of the other. So here, look, this is in the output function. So it says like between the printf, the printfs, the ret adder is set to. Oh, here's some comments. I kinda control ret, but only 1 byte right now. Need more stack control, please. If I can get some nice gadget like add RSP and ret, that might be kinda useful. Then ROP to win. Oh fucking wait, I can't just repeat this process as overwriting the pointer to the return address and repeatedly write on 1 byte for more freedom. About freedom of return address. Is that's the alternative thing we talked about, right?
Yeah, yeah.
So let's see. Both. I'm just gonna mute Slack for a quickly because otherwise this is gonna be horrible. Sorry about that. Yes. So okay, but was it only mrtumble who had looked at that, or was that the thing that kileak was looking at as well? So if we check back with kileak, he's still. I mean, he has found. So if we look at his exploit here and we try to, it looks like he claims that there is the libc address at offset 33 on the stack, and that he then could use this to get the base address and do the leak. So is that plausible? Could there be a
So there may be.
Yeah.
Obviously, all of these libc functions call other internal functions.
Yep.
And if they do it low enough on the stack,
Yep.
that's below the sort of bit where the printf is, then they will find a valid pointer.
Yep.
In which case they're doing the classic method. They're writing over that, doing a partial overwrite, and then later they'll try to point that to malloc hook or something like that, and they'll try to win that way, which is valid. It's definitely a way to go,
Yeah.
but it's a slower way to go than the intended method,
Yeah.
which it's still interesting to me that nobody's targeting that beautiful chain of pointers.
Nope. Yeah, it's very interesting.
It's like so much less pain than what they're going through now.
Yeah. So, checking with Lord Idiot again, doing some stack analysis here again. It's just printing out some information about these different. Oh yeah, he's now noticing that you have a full rel row. So again, for those who don't know about that, so the rel row protection is the relocation read only. So in older binaries or where you don't have this exploit, a very typical thing you would do is that you would overwrite something in the global offset table. So that when you call some of these library functions like printf, you would instead call system. But with full rel row, the global offset table is read only, so you cannot overwrite those entries.
Right. It's used as sort of cache on the fly. So when you need a function, it looks it up if it hasn't looked it up before and stores it in this cache.
Yeah.
And then it doesn't need to look it up next time. But with full railroad, it does that at load time, so it doesn't need to do it again. And also it does some other stuff, like you can't write to some other pointers like detours, ctours, all that sort of stuff.
Yep.
So it basically tries to take a bunch of nice friendly pointers out of your control.
Yeah, so it's quite powerful protection, but it's
Yeah, so once you have that, you're definitely looking to go into some library somewhere.
So we're checking back with Laxa. He is. I'm trying to read his exploit here, but
Okay, so he's the smartest one here, right? So look at this. You see that on line 53?
yeah,
Well, he moved it. Yeah, okay, it is line 53. Do you see he's pitting a null byte and then an address
Oh, yeah.
in that buffer?
yep,
That's the buffer I was expecting these guys would be looking at.
yep,
But none of the others are.
yeah, and then he's building his rob chain down there at the bottom as well.
Yeah.
So
Okay, so he's answering.
okay, so to explain this, so in the program, it reads input right to this global buffer, and it reads like a kilobyte of data, and then it checks with strlen, and if it's longer than 13 characters or something, it will exit. But I mean, strlen, of course, it measures the length of a string, which is null terminated. So as long as you do at most 13 characters, then a null byte, and then you can put whatever you want in there, because this is read with fgets, right? So I mean, the null byte doesn't stop the reading of data, or is it just a straight up read even?
I don't even remember.
Either way, sending a null byte doesn't stop it from reading input, so it will continue to write to this global buffer. So you can put additional data in there, even though you can't use that data in your printf exploitation.
Right, so you can use that data for something else, and in his case, what I imagine he's doing is he found that sort of side libc leak. He's using that, but he's also using the trampoline buffer directly. So I think he's just going to make a tiny little rock chain there in order to pop a shell. I don't know that he's going to pivot to the bigger buffer.
Yeah.
So it's a slightly different method, but it's definitely valid.
Yeah.
You could make it work for sure. Like, if he has a libc leak, then that's all he needs, basically. Because what does he need to do? He needs to pop RDI with the bin/sh string, and then just launch system.
Yep.
Oh, by the way, so which version of libc is this? Because there is another problem with these system payloads on libc these days.
Yeah, so this is 2.27. It's the we are basing this on Ubuntu 18.04, the Docker image.
Right, so then it is compiled with floating point registers, which means that the stack must be aligned by the time it calls some stuff induced system. So sometimes that'll cause these nasty little crashes. I don't want to get into why, because I just got annoyed with that at this last CTF. So David Buchanan is asking, I wonder if that libc leak might only work on his local machine, since the stack layout can be slightly different. And he's right, and that is possible, but I have sort of worked on the assumption that these guys must be checking it remotely, right? Like, as soon as they get that good leak, at least I know I would sort of check it remotely just to confirm. But yeah, that's something to look out for.
Yeah. Okay, so I'm trying to see here what progress they're making. So we can look here at kileak. So he's using Ropper to looking for gadgets.
Yeah, we've seen that one be handy in the past.
Oh yeah, look. I mean, so when it comes to these tools to help you find gadgets, we've seen ROP Gadget, Ropper, and then RP++.
Yeah.
Which I've started using quite a lot recently, since I saw it here in the second episode, I think it was.
Yeah, with Voss.
Yep. So that's cool.
Yeah, it's just amazing because sometimes one will miss something that the other one will get. It's a crapshoot sometimes.
Yeah. So what he's looking for, he looked for this pop RDI gadget.
So that's the first argument to call the function,
Yeah.
and then RSI would be the second argument, and he is trying to make a ROP chain.
Yes. So he will use the pop RDI to put the an address to the /bin/sh address into the first argument.
Yep. And then I imagine system.
Yes. Why? I mean, system only takes one argument, right? So
It does, yeah.
So why is he doing the pop?
He might be
RSI?
smart enough to know that the stack needs to be aligned.
Yes, but in that
For that
case,
problem
why
that we
did he
discussed.
specifically search for pop RSI in
I
the
don't know.
Ropper?
I would have used rets myself.
Yeah. So
If it's unaligned, you only need one address to make it aligned, so that the
that would
XMM
just be a single ret.
right.
So that's kind of interesting how in a ROP chain, a single ret becomes like the equivalent of a NOP in like shell code. So there's like this relationship between them.
Yeah, like knob slide became ret slide.
Whoa! So we have a solve.
Wow, there it is. Whoa, unexpected, right?
Yeah, we even didn't see that coming. So let's stop the fire
I have
first.
to say that is definitely slightly unintended.
Yeah. So let's. I mean, the others can keep on running, but let's bring Lord Idiot in here in the channel, and so.
User was moved to your channel.
Hello, Lord Idiot. Are you here on TeamSpeak?
I haven't heard him on audio. this
No,
whole
he
time.
said he just hello. Hey, congratulations.
Well done.
You were the first one to solve it. So how we would like just to, if you could maybe just walk us through what you did in your exploit, if that's possible.
Oh, yeah, sure.
So I have your
Okay,
I
so
have your screen
sorry.
on the stream now, so you can show things on the screen as well.
Okay. So the binary is a loop with a format string bug,
Yeah.
and the input is restricted to 13 bytes, right?
Yeah.
Um, yeah, but then the thing is our buffer is written in the BSS. So the normal way of doing format strings with writing an address in stack won't work. So the first thing to do is just to leak all the pointers in the stack. And then in order to get a write primitive, I use one of the pointers in the stack that point to another stack pointer. So yeah, so in this case, in the stack, at this address, there is a pointer in the stack that points to another pointer. And so what I can do is I can use the format string bug to override the least significant byte of this.
Yep.
And then this acts like a cursor of some sort, which is over here, right? So I just keep increasing this cursor and I write 1 byte at a time or 2 bytes at a time in the address that is a bit lower over here. So then now I'm able to write an arbitrary byte, arbitrary address in the stack. So using the format string, I can write to the, what did I write to?
Okay.
Oh yeah, so at first I thought there was no railroad. So I tried writing to the GOT, but in the end I decided to write to the stack return point, saved EIP of main.
Okay.
Yeah. Yeah, so when main finishes, it will return to the one gadget.
Okay. Cool. Nice.
So it's kind of interesting because I'm starting to wonder if was this recompiled right before?
No, I have not run any compilation.
Okay, so that libc leak, yeah, then you could do the one gadget. You don't need to do any sort of pivot.
Yeah.
So it's legit. I mean, but yeah, there was that remnant of that last little libc pointer on the stack.
Yeah. And this really shows how, that small little crack, you like if you get it, then you can just pry the whole thing open.
Right.
So
Good stuff.
good job. This was not the intended solution, but it's a good solution, and congratulations again. So let's see, we have been running for an hour basically. So I think we're gonna let them continue for a little bit to see if if we get a second finish. It would be cool to see if anyone gets that other solution.
But to be fair, what's the point if there's a libc pointer floating about?
Well,
You know
yeah,
what I mean?
that's true.
Yeah,
So what was the intended solution?
You write to RBP, the chain of base pointers that point to each other.
Uh-huh.
There was supposed to be no libc pointers on the stack that you could reach or even leak. And so there was a chain of base pointers, and you would just write to the low address of one of those base pointers, and then you could, because it leave rets 3 times by the time you hit main exit, it would slowly pivot the stack, and then you would hit the trampoline in the again buffer. When it asks you if you want to play again, there's a little buffer that's on the stack. And then maybe you could just bounce from there up to the data section or something like that.
Oh, so we moved the stack up into the BSS.
Yeah, that was the idea. But if there was a dangling libc pointer and you took advantage of it like a killer, like a ninja.
That's nice. Okay, so yeah, maybe we should then actually just.
Well, I want to see like more pony, some ponography.
That's a new one. No, but very well done, Lord Idiot again, and thanks for joining in with such short notice. It was good that we had a full lineup with 4 players, so that's good.
And I must say that your name is a lie. You are neither a lord, sir, or an idiot.
That's good. Well, yeah. Should we just? Yeah, I mean, you're of course free to continue watching the stream if you want, Lord Idiot. But so we'll see how we will. So, Bob,
What
would you
would you
say?
rate the challenge, Lord Idiot?
Uh,
CTF terms, like 100 to 500.
100 to 500. I think it's 200.
2? Wow, okay.
Yeah.
Okay, well, I was thinking 150, but 2's
Oh.
close enough,
Well, I mean, it's somewhere around there. It's
for sure.
it's not the 100. It's not like the first pony will do. It's not the 500, which will drive you mad for 8 hours. So
8.
um,
More like 24.
we're not doing a marathon episode here, right? So yeah. Well, let's see. Like I'm trying to check with the other ones, and it doesn't really look like anyone is going for the like the intended solution, right? We have
Yeah, there's just no point if you
no,
have that pointer.
yeah,
Like, it just sort of breaks everything. But it is interesting that none of them looked at the base pointers, because whenever you're looking at the stack, you go like, oh shit, I got this format string bug. What can I write to? Your eyes just skip over that chain of base pointers every time.
yeah. So yeah, what do you say, Bob? I mean, we haven't really gone on for that long, but on the other hand, we set the goal to just over like roughly an hour. So I think we kind of hit the target. So I'm thinking about if we should just wrap this up and get the other players in here and
Yeah, it's your call, man.
not go on for like 10 hours. So yeah, I will just bring everyone in here and we can have a little bit of a chat about this. So
User was moved to your channel. User was moved to your channel. User was moved to your channel.
hello everyone.
Hey.
Hey,
Hello.
you know what? Lord Idiot solved the challenge. So and yeah, so we are breaking this now, or and we have a winner basically.
Yeah.
Can we continue for second or not?
No, just drop it.
I mean, you want to?
It depends if anybody else wants to.
I guess that's a no.
That's a no.
That's a no.
That's unfortunate. Mr. Tumble will have to basically have you back on another episode. Then that just has to be the case.
Indeed.
Yeah.
I'll give you an honorary second right now.
Thank you very much.
No, but maybe we can just have a little bit of a chat here around like what you were going for and what the status was for everyone. So yeah, Mr. Tumble, what how far have you come, and like what were you doing right now, and what was the target basically?
So I had rip control basically, and right now I was trying to like de-randomize libc and then just point the return address at one gadget.
Okay, cool. How did you achieve the rip control?
There was a pointer to there was a stack pointer. There was a pointer on the stack pointing to the stack, which pointed to the return address. So use the pointer to the stack pointer to overwrite the stack pointer to point to the return address, and then use the second stack pointer which you've overwritten to overwrite the return address. So you create a pointer to the return address on the stack, and then you write it.
So it sounds like you were writing to the base pointer, and then you changed the next base pointer in the chain to point to the return address.
Yeah, I think it was the base pointer. Yeah, but like I wasn't thinking about that. But yeah.
And then you were like moving it one step at a time, then the right.
Well, yeah, but I was overwriting the wrong return address. I was overwriting the return address for output, and obviously I needed to loop around again. I needed that return address. So I was then just trying to figure out offsets and stuff. The plan was to just do that in a loop and overwrite like the address as exit, or like because the return address for main is exit. So I was just gonna overwrite that, but then I realized I didn't have the libc loaded and all that shit, and then I got bogged down in libc stuff, and then I was trying to figure out offsets, and then and we finished.
Yeah, but that was essentially then the same technique as Lord Idiot, I guess, by using this chain of base pointers to overwrite the return address. Then, so kileak, how was it going for you?
Yeah, tried pretty much the same.
Okay.
Use the stack pointer, try to write to the return address, but obviously I messed up RBP, so the leaf was misaligned, and so it didn't hit my return address anymore.
Oh, that's unfortunate. Yeah.
What was the libc pointer that you guys were leaking?
Exit.
Right, it resolved exit. Okay, I got you.
Oh, that's interesting. Laxa, so what was you doing? How far did you come?
I was a bit lost. I think I took the wrong approach. I wanted to do a ROP, and I had like almost anything except that you obviously can't write any address in BSS and be able to use it to ROP. And I found out that on the read of the yes sir inputs, you can the buffer is longer than expected, and I thought I could use I thought I could put addresses in it and then use them with the printf, but for some reason the printf functions just, I don't know, overrides if you go before offset 5. You know, I put dead beef and dead beef, and they're supposed to be at offset 1 and 2. If you use like percentage $1 you should have dead beef, but for some reason it's not there. So
Isn't that number 1 and 2? Wouldn't that be the RDI and RSI registers?
yeah, that's possible. That's possible. I don't know what's happening, but if you look like at the stack, when you execute printf at offset 0, you got the yes sir. Then after you got 2 more 8-byte values that you can control, but they are like probably overwritten during the printf or something.
I see.
So that's interesting because you found that buffer that no one else found, which is that yes sir sort of buffer. And in the intended method where you don't get the libc leak, from just running it, you have to make a ROP chain to get that later. You have to use that buffer to trampoline into BSS. So I thought that was like well spotted by you. You're definitely showing your colors there.
Yeah, so that's cool. So yeah, it's interesting that people were kind of going in the same direction. Have any other comments or something to say about the challenge today?
Did anybody else do this in IDA?
Sorry, what?
Oh yeah, I did it in IDA.
They all did, yeah.
When you're working with stack buffers with alloc in IDA, the decompilation is just disgusting, and I just assumed that all the shifting and the multiplying was just pointing at the stack buffer.
Yeah, right.
I just ignored all that and went to printf.
Yeah.
I think Gidra actually handles this better, but I've not tried it.
Yeah. So the all of that crap was, basically just pointless stuff to force the leavret insertion.
Yeah, the initial idea where you couldn't get the libc leak is that you write to the base pointer, and then it's going to do leavret as it works its way down to main. And then as you exit from main, you control the stack points at that point. So you would obviously point it towards your buffer on the stack, which is the yes sir buffer, use that to pivot into the data section, and there you could do whatever you wanted. You'd have freedom. But of course, I think we might have messed up slightly as we were rushing this out. So you guys found a better method.
Yeah. But I mean, that's also cool and all. So yeah, I think.
Pwn to pwn.
Yep. And I think that, do we have any like questions from the viewers or anything like that? Otherwise,
Yeah, I see a guy asking about kernel exploitation, and I know a guy who could make a nice, quick kernel exploitation challenge.
Yeah, that would be interesting to see. We haven't had anything like that so far. It's been no heap stuff and no kernel stuff so far, right?
So far, yeah. I'm not going to put a heap challenge in front of kileak.
we have to pick the challenges in carefully according to the participants, I think.
Yeah, or else we get that Jinmo situation again.
Oh yeah, no, that was sick. But yeah,
Hey, so I was wondering if the other guys could give, I know they didn't all finish it, but they all got the right idea. So if you would rate this between standard sort of CTF rating 100 to 500.
in like difficulty or yeah.
Yeah,
150.
nice.
As we know that you want to hear at 150.
That's not what Lord Idiot said though. So
Yeah, you saying 200, so
yeah.
Yeah, I'd say 200 also.
okay.
Cool. We also get a suggestion to some ARM exploitation, or basically, I mean, you can generalize that, other architectures, and that's also, one thing we might do in a later episode.
Well, as Laxa knows all too well, I love ARM and I love kernel, so I think we can whip something up.
Yeah, that's cool. But yeah, so let's just then wrap this up, and thank you everyone for participating, and congratulations again to Lord Idiot. Oh yeah, no, I almost forgot. So as usual, then not right now because people have been sitting and watching this for an hour, but tomorrow at the same time at 4, we will be releasing the community challenge, and the rules are the same as previous months. The first one to solve the community challenge, which will be a pwnable challenge that we will put up on the website pwny.racing. I will put a link in the description as well. We will put up the community challenge tomorrow at 2 p.m. UTC, and the first one to solve it will be invited to the next episode of Pwny Racing. And this is how Laxa got into this episode, for example. We got a suggestion here for a Risk V challenge. One day, that's probably something that's going to happen.
Yeah, I hope that was said with, tongue in cheek.
I mean, well. Anyway, community challenge tomorrow at 2 UTC. Which was the same time as the stream started. And do we have anything else of importance to say, Bob?
Yeah, I want to say I hope all of these guys come back because, I mean, they're all killers, obviously. Laxa, you crush it for ages. Mr. Tumble, I can't wait to see you taking the UK all the way up. kileak, your reputation precedes you. And then obviously, I didn't expect it, but Lord Idiot, you are a badass.
Yeah, definitely, everyone. We hope to have you back here on another episode. And I'm just, trying to think if there's like stuff coming up or other things to be on the lookout for. But
you are running a massive CTF in 2 weeks, so
yeah,
I guess people can't.
No, it's the
but
finals,
still.
so it's the Midnight Sun finals coming up in Stockholm. But I mean, if you happen to be in Stockholm in the middle of June, you are very much welcome to come by and say say hi to people and watch there will be some physically related challenges, or there's some cool stuff. But anyway, we will see you again in the next episode, which will be in about a month or so again. We will post the dates on the website and here on YouTube and Twitter and so on. So be on the lookout for that. Don't forget the community challenge tomorrow. And with that, thank you very much for watching.